The internet is a wide area network, the wide area network, and that's generally the network that we want to communicate with eventually. So we're going to talk about the general structure of a wide area network. These pictures are pretty high level, but they give you the general picture of what a wide area network like the internet would be, how it's composed, and what the different components are inside there. So a wide area network like the internet is a network. It's a combination of local area networks. So if you think about the internet, it's very ad hoc, right? There's no regularity, meaning anyone can, like right now, if I wanted to, I could build a network right here in this building, and it would be added to the internet. I could give it a name, and it would be part of the internet. And so the internet isn't one of these networks that's controlled and well structured, right? Unlike the local area networks that you see at your place of work or at a school, where you have some IT department, IT group, and they constrain how the thing is put in there. They say, look, every time a machine comes in here, you got to register it in this way, and we only approve of this and that, and they put the equipment into the building for you and all that, so it's very structured. But generally, wide area in the internet specifically is pretty unstructured, right? I mean, there is some minimal structure, there has to be, but it's fairly unstructured. So at a low level, at the leaf level, right, local area network level, there can be any number of different local area network types involved in the internet, right? Just depending on what people want locally. So you start off with local area networks. So we got our local area network, and you got several hosts, host 1, 2, 3, and these hosts are just computational devices that talk on the network. So basically computers or IoT devices. And they're all communicating with a component. Now in this picture we got a switch. It could be a hub or a switch. A hub is a network component that it has several input ports. We're assuming wired right now. This can also be all done wirelessly, but let's talk wired for a minute. It's got several input ports, input-output ports. Like in this case, this switch has 3 ports, right? So you could have a hub there that has 3, and anytime data is a packet is sent on one of the ports, it is reflected, copied to the other ports. So if host 1 sends a message to anybody, that same message is spit out to host 2 and 3. So both of them get the message. That's all what a hub does. A switch is more intelligent. A switch says, look, it looks at the packet header to see where it's going. So if host 1 sends a message to the switch, and the destination of that message is host 3, then the switch there is smart enough to know that that message should only be sent to host 3, not to host 2. So the switch is more intelligent about where it sends messages to, where a host is more dumb. But you got a host or switch somewhere in there that transmits data between the different input ports and output ports. So generally LANs look like this. Now you can have larger LANs which involve multiple protocols. So you see on the left you got a LAN, on the right you got a LAN. You can combine them with a bridge. The bridge can communicate different LAN protocols. So maybe you've got these LANs, and one group, one department in the university decides they want to use this particular protocol. Another department uses another particular protocol, but they want their machines to communicate, so they put a bridge in between, and the bridge basically talks both protocols and can do conversions between the two. So you can group together these LANs into larger LAN components, let's call them. So it's not a single LAN anymore. It can have multiple protocols that are glued together by this bridge. Now, a wide area network is a set of these LANs all put together with routers. So you can, if you look at this network, this is, by the way, a vastly simplified internet, but you got a bunch of LANs, and they are all communicating to routers. And then the routers can communicate with each other to pass data. So one LAN can communicate with a completely different LAN through these routers. So you notice every message that's sent from one machine to another has many hops, what are called hops. Has to go through several different machines before it reaches its destination. So if you want to go from one LAN to another, you might leave this LAN, go to this router, then go to another router, then finally back to the destination LAN, and then to the host. So there's a sequence of hops. It's called a route, actually, of hops that you have to go through to reach your destination. And so these routers, they're organized. This is very simple. It's only 3, but in reality, there's a vast hierarchy of these routers. And they are all intelligent. They have intelligent protocols to determine where they should send the packet next to reach its destination most quickly and avoid flow. You know, you don't want to have one router that receives too much data. Maybe all the messages are running through one router. You'd like to spread out that data across the entire network so that the one router doesn't get bogged down. So there are lots of protocols along those lines. And the internet involves protocols like that to sort of level out the traffic. Thank you.